in this video I'll be doing problem 63. It says a sinusoidally varying driving force is applied to a dampened harmonic oscillator of a force constant K and mass m. If the damping constant has a value B1, the amplitude is A1. When the driving angular frequency equals root K over m in terms of A amplitude 1, what is the amplitude for the same driving frequency and the same driving frequency amplitude F max if the damping constant is A, 3B1 and B, B1 over 2. Alright, so first of all, we know that the driving angular frequency equals root K over m. This equals root K over m. So the equation for amplitude with this problem, with the damping force, is so A equals 1 equals F max root K minus M omega D squared. Hold on. And this whole thing right here squared plus B1 squared times omega D squared. So since we know that omega D equals root K over m, we know that omega D squared equals K over m. So if we plug that into here, plug K over m here, it would be m times K over m. So these would cancel out and end up being K minus K. So this whole part becomes 0. And this becomes K over m. Yeah. So then we'll have A1 equals F max over root B1 squared times K over m. So then A1, amplitude 1 equals F max of B1 times root K over m. And yeah, that's what it is. So then if we plug in 3B1 here, for A, it wants to know what the amplitude will be if B equals 3B1. So we'll have amplitude 2 equals F max over 3B1 times root K over m. So then we just want to set this equal to A1. Yeah. So we set these equal to each other. B1 times root K over m. And to make these two equal, you'd have to multiply this by 3. Yeah, you'd have to multiply this by 3. So you'd get times 3 times 3. So 3 A2 equals A1. So you just divide by 3 and you get that A2 equals A1 over 3. So for part A, the amplitude is 1/3 A1. And for part B, pretty much do the same thing, but we set this B to be 1/2, so A3 equals F max over B 1/2 times root K over M. Set that equal to F max over B 1 root K over M. So then you'd have to multiply by, or you'd actually have to divide by 2, because this 2 will come up here. So you have to divide by 2 to make it equal to A1. So divide by 2, so A3 over 2 equals A1. So then you just multiply by 2 on both sides over here, and you get A3 equals 2A1. So this one is twice the size of the original amplitude for part B. So yeah, you have part A is 1/3 amplitude A1, and part B is twice the size of amplitude 1, which I guess you could just figure out by instead just setting the amplitudes equal to each other. So you'd have B2 equals 3B1, and you divide by 3 right there, and you'd have B2 over 3 equals B1. So then you could put 1/3 the amplitude, because all the other numbers are constants, so they'd cancel out. And same with this other side. B3 equals B1 over 2, and multiply by 2, so then you'd have 2B3 equals B1, which would just translate to the amplitude since the other numbers are constants. But anywho, A is 1/3 the amplitude, 1/3 the original amplitude, and B is twice the original amplitude, and that is problem 63.